Morning, everybody. We are in our final day of reviewing equations. So we are going to look at equations today as we're finding volumes of cylinders, spheres, and cones. So this is Unit 6 and the final unit of review. When we started Unit 6, the first thing we did is we watched Sphereland. So that was the sequel to Flatland. Then we identified some different solids. You guys had to name them based on their circular cross sections and if they came to a point at the top or if they were totally rounded. So we looked at different things, like this would be a cylinder, here's a sphere, here's a cone. This would not be any of those three things because it is a cube and its cross section is a square. The cereal box, its cross section is a rectangle. So we only wanted to look for things that had circular cross sections. We talked a little bit about rounding. We're dealing with irrational values in all of these problems because we're multiplying by pi, so rounding is going to be important. We took some volumes of all different solids. This was a coloring sheet. Here are our cylinder notes. So we put our examples of our cylinders from that first page. We stuck them in the envelope, and we talked about how the volume of a cylinder is equal to the area of the base times the height. Here's some examples of volumes of cylinders. Here's our volumes of cones. So we put all of our cone examples into this envelope. And we talked about how the volume of the cone is equal to the volume of a cylinder with the same measurements, but then we multiply it by 1/3 or divide by 3. We did some examples of cones, and then we moved on to spheres. So here's our sphere examples from that page. We stuck them all in this little envelope. We talked about where the volume of the sphere came from. So it's the area of each of these individual little bases. We looked at an equation that put this into perspective for us. Examples of spheres. This was our study guide. Getting ready for our test, we did volumes of cylinders, volumes of cones, volumes of spheres. And then finally, you guys had to make your robot and find the total composite volume of your entire robot. After that, we just had our test. So now, instead of finding the volumes, what we're going to be looking for is the missing values when we already know the volume. So this requires you to solve some equations, which is something we couldn't have really done before, so we talked about it, but we didn't actually solve them. So let's look at that now. In number 1, we have a cylinder. We know the radius, we don't know the height, and we do know the volume. So we're going to plug in what we know. I know that 24 is equal to pi times that radius of 2 squared times the height. I'm going to clean my equation up a little bit before I try to solve for the variable. So right here, I need to make sure to do my exponent first, and then we'll multiply. So I have 24 equals 2 squared is 4. So I'm going to make this 4 pi times the height. Now if I want my height by itself, I need to get rid of this 4 pi. It's being multiplied by the height, so I'm going to divide both sides by the 4 pi. So these are going to cancel. Height is by itself. And this is what I need to plug into my calculator. So I know we don't have graphing calculators at home. You could use your phones. You could plug in 3.14 for pi. Or what I chose to do is I just did a quick Google search on my laptop, and I found this one. The good thing about this one is as I type things into it, it's going to show me exactly what I typed in, so I can see that it's doing order of operations. So I want 24 divided by 4. Oops, I want that in parentheses, because I want to make sure the 4 pi gets multiplied first. All right, and now I'm going to calculate. I know you guys can't see that very well, but I have 1.9098591. We can expect it to go on forever. So what I'm going to do is round. So here's what it says in my calculator. Okay, and I'm going to round that. I'm going to go to the nearest tenth. So 1.9, here's the tenth. This is a 0, which means I'm not rounding that value up. So I have about 1.9 is my height. All right, let's look at number 2. I have no radius, I have a height, I have a volume. So I'm gonna plug in what I know. I have 140 equals pi times my radius squared times my height, which is 5. So I'm looking to get this radius squared by itself. So I'm gonna need to divide by both the 5 and the pi. I'm gonna do that in one step. I'm gonna divide both sides by 5 pi. It gets rid of the 5 and it gets rid of the pi. So I'm gonna have r squared equals whatever I get right here. So I'm gonna plug that into my calculator. I have my calculator right over here. So I'm typing in 140 divided by, I need those parentheses again, and I want 5 pi. Okay, we're gonna divide. I have 8.912676813115. Okay, so I have a whole bunch of stuff right here. So this is that 8.9 blah, 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 blah. But I'm not done. I need the r by itself. So the opposite of squaring something is the square root. So I need to take the square root of both sides. While I still have that number in my calculator, I'm gonna see if it'll let me take the square root. That way I don't have to type it all in. So I'm right here. Let's see if it lets me. Nope, I'm gonna have to type it in. I'm gonna round it to the nearest tenth. So square root of 8.9. So now because I had to round the problem early, it's not gonna be exact, it's not gonna be perfect, but we're gonna be close. Let's calculate. 2.98. All right, so I'm gonna write down what I have. I have 2.98328677804. I can keep going forever, right? But let's round this to the nearest tenth. So if I want to round it to this, I have to look at the number next to it. It's above a 5, so I need to round this up. So that means it's going to be 3. All right, moving on to the next one. I have the volume of a cone. I know the radius, I know the volume. I'm looking for the height. So let's plug in what we know. Volume is 5. It's equal to 1/3 times pi times my radius squared times the height. So let's clean up the equation. 1 squared is 1, so I can just ignore that for now. Pi is really close to 3. 1/3 of 3 is 1. So I can just guess that I'm not going to cancel them out, but let's say these almost cancel each other out. I have 5 equals height, so I can assume that my answer is going to be really close to 5. I'm going to do this one in 2 steps. Let's get rid of the fraction first. I'm going to multiply both sides of my equation by 3. That's going to get rid of this fraction. It's going to make it look a lot easier for us. So now I'm left with 15 equals pi times the height. So all I have left to do is divide by pi. So I'm going to go back into my calculator. And I'm going to do 15 divided by pi. I know you guys can't see, the light is really weird there. 4.774648292276. I'm going to round that to the nearest tenth on my paper. So first I'm going to write down as many numbers as I can fit. I have 4.77, we'll stop there. Let's round that to the 10th. So I want this number. We looked at the number next to it. It's higher than a 5, which means this has to go up. So I have that the height is about 4.8. All right, we've got one more problem. We are looking at a sphere. We do not know its radius. Oh, we don't have the volume written down. That was smart. The volume of this one was, hold on, let me look. This one was 16. All right, let's plug it in. I have 16 equals 4/3 pi r cubed. All right, let's see what we can do here. I'm going to get rid of the 4/3 first. I'm going to multiply both sides of my equation by its reciprocal. It gets rid of the whole fraction. Look, I can even cancel some stuff out over here. That makes my life a lot easier, right? So I have 12 equals, all that's left is pi times my radius cubed. Let's get rid of the pi. So these are gone. I have r cubed equals 12 divided by pi. Let's round this. 12 divided by pi would be 12 divided by 3-ish, right? I didn't pick very good numbers for you here. Let's take the cube root of both sides. What is the cube root of 4? I'm gonna leave mine as the cube root of 4 for right now because I don't think my calculator can do that for me. What we're looking for is something times itself 3 times. That would give you 4. So 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. So it's 1 point something.